Function lies between 0 and 1, so it's never negative, and we're looking at values of x between 0 and 1. We're told the trapezium rule with n equal intervals is used to estimate the area under the graph, and this produces an underestimate. So let me sketch out what maybe the function looks like. We don't know for sure, but it's still going to help us along the way. So it could be like a decreasing function such as this. And then I could split it into some trapezia. So maybe I'm just going to go with 4 trapezia. Okay, I know it's n in general, but this still demonstrates what's going on. They should be equal. It might not be perfect on my sketch. So here I would be fitting then straight lines between these, and you can see that if I find the area of these trapezia, I will be missing these gaps. I will get an underestimate. Because with my trapezium rule, I'll find this blue area, whereas really I should have been finding this bit as well. Okay, well, at least we've got that set up. So we've got to think what would happen if we now use the trapezium rule for f of x plus 1? Would that still create an underestimate or would it be an overestimate? Now, all that happens when you have f of x plus 1 is you get a translation by 1 in the y direction. So all the trapezium would just become taller as the function would be. We'd still get the same sort of underestimate. I mean, a different percentage, but actually the same amount as the magnitude, the bit that we've missed out. If we stretch it, then it would become, we just, oh, it doesn't quite work, but it would just get taller. So it wouldn't actually, we'd still get the same underestimate, just these gaps would get sort of taller as well. It would still be an underestimate. Let's look at the next one. This would be a translation by -1 in the x direction, and I'm integrating between 0 and -1 as well. So we'd get exactly the same answer because this just moves to here, and then I find the same integral. So still an underestimate. F of minus x is then a reflection in the y-axis. The function would end up looking like this, and I'm integrating between 0 and -1. I'd get exactly the same answer again. So still an underestimate, which kind of means just by deduction the answer has to be E. But we'll look at it in a bit more detail actually. So I'm going to separate into two integrals. I've got the integral from 1, like just 1, sorry, between 0 and 1, and I'm minusing the integral from 0 to 1 of f of x. So when I apply the trapezium rule to this aspect of it, you could actually do it separately. You'd get exactly the right amount because this is just a horizontal line. So it's all about this part of the function. So this is a reflection in the x-axis. It would end up coming down like that. So when I now find my trapezia, I've again got the same gaps as before, but what this will mean is that I'm going to get a negative for this integral, by the way, and my negative value will not be as negative as the actual value, which is why it's going to be an overestimate. So although the size of the integral, if we were to take the positive value, is still going to be below the actual, when we think about it as a negative, maybe for the blue one, we got something like, I don't know, 0.7, and the actual value is 0.8. That's what is an underestimate. Whereas now for this one, for this green bit, the trapezia, I'm going to get minus 0.7, whereas the actual answer would be minus 0.8. Just trying to clarify a little bit more. So actually, yes, it is an overestimate because it's above the actual value. The answer is E. That's our overestimate.